In this chapter, we first define what do you mean by point object or rigid body. Suppose you have a body like this, and if you apply force on it, there will be only one sense of motion to this. You'll say it will move along straight line only, or it will have translational motion only. But suppose you have a sphere. If you apply a force to this point, or this point, depending upon application of force to these points, this body will move in different sense. Let's say if you apply this force, so it will move along this direction or a straight path. If you apply force at this point, it will move along this direction. If you apply force to this part, it will move along this direction. So depending upon position of force, motion of body will be different. Is it clear?
Yes, sir.
Now, using these two terms, we may define first, in left-hand side, we have a body whose dimension is very small as compared to its influencing surrounding. So it will be termed as point object. So if you apply a force on it, it will move only in one sense, that will be a straight line. So if dimension of body is small as compared to its influencing surrounding, that will be termed as point object. Khalid, is it clear?
Yes, sir.
In the second example, I have given you a sphere or a solid body whose dimension is large enough so that if you apply force at different position, it will move in different sense. So if dimension of body is comparable or large enough as compared to its influencing surrounding, that would be termed as rigid body, or a body having large number of point object. So if dimension of a body is large as compared to its influencing surrounding, that will be termed as rigid body. Now from this we can conclude point object will move only in one sense, but rigid body will move on depending upon action of forces and point of application of force. Now, first write it down till this part. Nikhil,
Good evening, sir.
Evening.
Yes, sir. I'll be continuing this batch.
Okay.
Sir, by when will this chapter get over, sir?
We have just started this.
Okay, sir.
This is the first class of this chapter.
Oh, okay, sir. Okay. Work, energy, and power, right, sir?
No. Chapter number 7, that is rotational motion.
Oh, okay, sir.
Done, sir.
Salman, you have written?
Yes, sir, done.
Nikhil, you have done?
Yes, sir. I have done.
Okay. So before this chapter, from chapter 2nd to chapter 6th, we treat all object to be point object. But from now onward, we define object, point object, and rigid body in two different sense. So first is concept of center of mass. Suppose if you have a hammer and if you throw in air, I'm just neglecting the effect of gravity. So it will move like this. It means it will rotate like this. During this motion, you will observe there is a point which is going along straight path irrespective of all other point which will revolve around this given point. Is it clear? So you'll say all of the other points are moving around this particular red point, and this red point is going along straight path like this. So from this we can say in all rigid body, there will be a point on which total action or impact of action, whether it will be momentum, force, or any action, will be confined. It means if you add individual forces acting on individual particle, which will equals to the total action acting on this given point. So this point on which total action of force, linear momentum, or any other action confined, this point is termed as center of mass. Is it clear? Khalid?
Yes, sir.
Clear, sir. Clear.
Yes, sir.
So center of mass is nothing but a point in a rigid body where we just assume that total mass must be concentrated at this point so that total action must be confined at this point. So to relate a rigid body to point object so that we may calculate total impact of force, total impact of linear momentum. We define concept of center of mass. So we can say a point in a rigid body where total mass of a body is assumed to be concentrated. It means total impact of force, momentum must be confined at this point. Is it clear?
Yes, sir.
Okay, just write it down.
There, like, not only rigid bodies have this center of mass, right?
In all of, just 1 minute. In all of previous chapter, I had defined you object to be point object. It means the dimension of body is quite small as compared to its influencing factor, that influencing force, momentum, work, energy, and so on. So we define that body having point object, it means total mass concentrated at this point, so that total action confined to that only. But now we are considering the dimension of body to be large enough so that it may vary from application of force to different point to different point. So in that body, we define a point on which total impact of force or total impact of linear momentum must be coincide or confined so that it will define or treat it as point object if you apply force to that point only, instead of calculating individually to all individual point. Is it clear?
Oh, okay.
Let me define you giving one example. You all have written till this part?
Yes, sir.
Suppose a body having system of different point object, let's say this, 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 and this, and all are connected like this. Now, if you apply force, momentum, due to which each body will have some velocity, acceleration, and so on. Now, if you have to add them all to find net acceleration, so you will define net acceleration is equals to total force, that is force on first body, force on second body, force on third body, force on fourth, and force on fifth, divide by total mass, that is m1 plus m2 plus m3 plus m4 plus m5. Using second law, we can say, instead of doing this whole calculation, you will say there will be a point in this rigid body. Let's say it will be at this point. If you apply total force to this point, and if you calculate acceleration to this, F net divided by total mass, it will be same as this part. So which one will be more easier for calculation? Left one or right one?
Sir, right one.
So this is the concept of center of mass. So why we define concept of center of mass? So you'll say, instead of calculating individual term for a particular system, we will just take a point which is called center of mass, which will be treated as the whole impact of force, momentum, or any action will confine to this point only. Is it clear, Salman?
Yes, sir.
Why we need concept of center of mass, or why we need center of mass?
Yes, sir. I do
Okay.
understand.
I will prove it later. So first is how to calculate position of center of mass. For that, we first define the body to be of two different types. Position of center of mass. Instead of writing this whole center of mass, I will write COM or just C. So first is, suppose you have n number of particles and all are combined to form a system. So you'll say it will be a system of discrete particles. Discrete particle system. It means a system having individual particle and or are connected to each other. So for this, we use R center of mass equals to M1R1 plus M2R2 plus so on to MNRN divided by M1 plus M2 plus so on to Mn. It means, suppose this is coordinate system, a point particle having mass m1 is at this position, another at this, another at this, and so on. So for this whole system, we have to find position of center of mass. So just use this formula. Nikhil, is it clear?
Yes, sir, it's clear.
Okay. Now we may differentiate this particular position vector to x component, y component, and z component. We may write this position R as x center of mass equals to m1 x1, m2 x2 plus so on to mn xn divided by m1 plus m2 plus so on to mn. Similarly, we may write along y coordinate, along z coordinate, so on. Iba, is it clear?
Yes, sir.
Okay, just write it down. you all have written?
Yes, sir.
Nikhil?
Yes, sir, I wrote.
Now, let me give you one question. In HCl molecule, if separation between them is 1.27 angstrom, find position of center of mass from hydrogen. So how to approach any problem? So in this part, we have hydrogen and chlorine forming HCl molecule. So first try to rearrange them on axis. So let's say this is at origin and this will be along x-axis. Is it clear?
Yes, sir.
I've taken H or hydrogen to be at origin and next chlorine to be at this point along x-axis. Due to this representation, we may define its position or coordinate. Let's say for H, it will be 0, 0. Since chlorine is 1.27 angstrom away from hydrogen, so its position would be 1.27 angstrom times 0. Mass of hydrogen, let's say M1, is 1. Mass of chlorine is 35.5. It will be in terms of U. So use the above formula for discrete particle system. X center of mass will be M1 X1 plus M2 X2 divided by M1 plus M2. If you put all the values, M1 is 1, X1 is 0, M2 is 35.5, X2 is 1.27, divide by 1 plus 35.5. So on simplifying it, you will get 1.24 angstrom. Is it clear?
Yes, sir.
Salman, is it clear?
Yes, sir.
Okay, just write it down.
Done, sir.
Khalid? Okay,
Yes, sir. Done.
you have written? Okay. Let me give you another problem related to this. Suppose you have an equilateral triangle. This is 1 kg, 2 kg, 3 kg. Side is 4 meter. So find position of center of mass. So for any problem, first try to define coordinate axis. Let's say this is y-axis and this is x-axis. Depending upon this coordinate system, we may define its coordinate. So for this 1 kg, position will be 0, 0. For 2 kg, position will be 4, 0. Now, if you draw a vertical line, this angle is 60° as this is equilateral triangle. So this term will be x component and this will be y component to 3 kg body. So x will be equals to 4 times of cos 60°. Cos 60 is 1 by 2. So you will get x as 2. Similarly, y will be 4 times sine 60. Sine 60 is root 3 by 2. So you will get 2 root 3. It means position of 3 kg is 2 comma 2 root 3 meter. Is it clear? Hamza?
Yes, sir.
Okay. Now you have coordinate of each term. Put the above formula and try to find x center of mass and y center of mass. Try to solve. Just put the values in this part. You will get X center of mass. It will depend upon your choice. You will take M1 to be 1 kg, M1 to be 2 kg, and M3 to be 3 kg. Khalid, is it clear?
Yes, sir. Sir, we have to find both for X and Y or only for X?
Yes. Since this particular system is along XY plane, so you have to find for both. Good, Khalid. Hamza, you have solved?
Solving the second one, sir.
Okay.
Almost done.
Salman, you have solved?
Almost done, sir. Wait a second.
Okay. M1 is 1, x1 is 0, m2 is 2, x2 is 4, m3 is 3, and x3 is 2. Divide by m1, m2, m3. 1 into 0 will be 0, 2 into 4 will be 8, and 3 into 2 will be 6. 8 plus 6 will be 14. Divide by 6. So it will be just 7 by 3 meters. Is it clear, Hamza?
Yes, sir.
Now, if you put all the values in the second part, m1 is 1, y1 is 0, m2 is 2, y2 is 0, and m3 is 3, and y3 is 2 root 3. Divide by 1, 2, and 3. So on simplifying, you will get 6 root 3 divided by 6. 6 and 6 will cancel out. So you'll get root 3 only. Is it clear?
Yes, sir. Sir, the other answer is also right, but I have done it in decimal form.
Okay. It will be 2.333
Yes, sir.
like
But
this.
like I have estimated and wrote it 2.4.
You have rounded it to 4. Okay, no problem. Salman, is it clear?
Yes, sir. I was stuck with some calculation.
Okay. You all have written till this part?
Yes, sir.
Hiba, do you have any doubt?
No, sir.
Okay. So this is how we find center of mass for discrete particle system. Now let me define you some relation for binary system. It means a discrete particle system having 2 particles only. Suppose you have 2 body. First is M1 and second is M2 aligned along a straight line. Now let's assume origin to be at this point, which will be along center of mass of this particular system. So from this system or from this coordinate, we may define position of first body along left hand side and position of M2 is along right hand side, and total separation of particle is R. So you'll say R center of mass equals to M1 R1. R1 is along negative side, so minus of R1 plus M2 R2. R2 is along positive side, so plus of R2 divide by M1 plus M2. Since position of center of mass in this term is at origin, so this will be 0. So if you move this M1, M2 to the other side, you will get minus of M1 times R1 plus of M2 times R2 is equals to 0. Is it clear? Hamza, is it clear?
Yes, sir.
Now, if you rearrange it, move this M1, M2 to the other side, you will get M2 R2 equals to M1 R1. So M2 divided by M1 equals to R1 divided by R2. So in this relation, you will say mass of particle is inversely proportional to its position, as M2 is inversely proportional to R2. So you will say mass of body will be inversely proportional to distance from center of mass. It means greater the mass of the body, it will be at shortest path or shortest length from center of mass. It means center of mass would lie towards heavier body. So from this we can conclude position of center of mass will lie towards heavier body. Is it clear?
Yes, sir.
Khalid, is it clear?
Yes, sir.
Okay, just write it down. You all have written till this part.
Yes, sir.
Salman,
Yes, sir.
okay. Now from this we may conclude or calculate sum of term. As we have M1, R1 and negative sign plus M2, R2 equals to 0. You may write it as R1 plus R2 is equals to total separation between two particles. Now we have to combine these two equations to find the value of R1 and R2. So multiply this equation by M1. So M1 R1, M1 R2 equals to M1 R, and divide or subtract these two equations, you will get R2 equals to R1 divided by R1 plus R2 times total separation so R2 will be M1 divided by M1 plus M2 times total separation R, and R1 will be M2 divided by M1 plus M2 time total separation R. So you may use this formula to find position of center of mass if separation between two particles is known. Like in the previous problem or in the first problem for HCl molecule, I had given you separation between two molecules is 1.7 angstrom. So if you use this formula, R is equals to 1.7 angstrom, and you have to find position of first body from center of mass, that is R1. So R1 will be M2 divided by M1 plus M2 times R. M2 was 35.5, that is mass of chlorine. M1, 1 plus M2, 35.5, and whole multiplied by 1.7, and it should be 1.24 angstrom. Is it clear? So you get direct relation using this formula instead of drawing coordinate system and so on. Hamza, is it clear?
Yes, sir.
Okay. You all have written?
Yes, sir.
Khalid, any doubt?
No, sir.
Okay. So this is how we approach any discrete particle system. Now the next term is for continuous body. What do you mean by continuous body? So you'll say if mass is distributed uniformly on that entire body, that system is termed to be continuous body. So we first define distribution of mass. We mainly have three different types of distribution depending upon dimension of body. First is called linear distribution. Second is called aerial distribution. And third is volumetric distribution. Suppose you have a rod which having some length L and having mass m. So if you cut a portion of it, let's say from this point to this point, so we define a term that is lambda, which is linear mass density, and it should be equals to total mass of rod divided by total length, and it will be small mass of rod divided by its small length. So this lambda is termed as linear mass density. Is it clear? Hamza, is it clear?
Yes, sir.
Now suppose there is a sheet having some mass m distributed over area A. Now if you cut out a portion of it, so we define sigma equals to total mass of body divided by its total area, and should be equals to small mass of that segment divided by its small area. So this sigma for this distribution is termed as areal mass density. Now suppose there is a cube having mass m and volume v. If you cut out a portion of it, so rho equals to total mass divided by total volume, small mass divided by small volume. So this rho will be termed as volumetric mass density. Eba, is it clear?
Yes, sir.
Okay, just write it down.
Done, sir.
You have written?
Yes, sir. Done.
Now, depending upon these distribution, we may define formula for it. So the next term is position of center of mass for uniform distribution of mass. Uniform distribution of mass. Let's say x coordinate, it will be m1 x1, it was initially, plus m2 x2, and so on to mn xn divide by m1 plus m2 and so on to mn. Since it was a discrete particle system in which m1, m2, mn individually defined, but now if there is a particle in which mass is continuously distributed over its length, volume, area, and so on. So we define m1 to be delta m, and position of that will be defined by x. Now, if you sum up all these small segment, you will get total m1 x1 to that part. So let's say this is ith position, this is ith position, divide by summation delta m ith position. Now, since this mass is continuously distributed, so this sigma get transformed to sign of integration. X delta m will be dm divided by integration of dm. Is it clear? So for uniform distribution of mass, we use x equals to integration of x dm divided by integration of dm. Is it clear?
Yes, sir.
Khalid, is it clear? Khalid, is it clear?
Yes, sir.
Okay. Now, using this concept, let me give you suppose you have to find position of center of mass for uniform rod. Now suppose there is a rod which is aligned along x-axis, having some length L and having mass M. This is x-axis, this is y-axis. Is it clear?
Yes, sir.
So first, cut out a portion of it. Let's say at this point, it will have mass dm, having length dl, and it will be at x distance from this origin. Now first we define lambda, which is equals to total mass over total length, dm over dl, or you may write it as dx. Since it is along x-axis, so from this part, we can say dm equals to m over L times dx. Now, use this term in above formula, you will get x position of center of mass equals to integration of x times dm divided by integration of dm. If you put the value of dm, m by L times dx integration divide by dm is m by L times dx integration. M by L is constant, in numerator as well as denominator. So keep it outside. X times dx divided by m by L times dx. So these two terms will cancel out. So you're left with x dx divided by dx. Now we have to apply its limit. As this rod is extending from origin to this much amount of length. So its limit would be from 0 to L and from 0 to L. Now integrate it and simplify it, you'll get your answer. Is it clear?
Yes, sir.
Okay, just write it down first. For integration, we use if you have x raised to n times dx, just use this formula. Hamza, any problem while solving?
No, sir. Doing it. Sir, what about m divided by L?
As M by L and M by L is constant and in numerator and denominator, so these two terms will cancel out. Is it clear?
Yes, sir.
So you'll say center of mass of rod will lie at its midpoint. Tiba, is it clear?
Yes, sir.
Khalid, any doubt? Salman?
No, sir, no doubt.
Okay.
Done, sir.
Hamza, you have done?
Yes, sir, done.
Now from this, you can say for all symmetrical body, center of mass will lie at line of intersection of symmetry. For symmetrical body, center of mass will lie on the intersection of line of symmetry. Suppose you have a triangle. Or a triangular body. So if you draw a line which divides it into two equal halves along this direction, so this line will be termed as median. Similarly, if you draw a line of symmetry along this vertex, so this will be termed as median. And point of intersection of median is termed as centroid. So you'll say center of mass of triangular body will lie at its centroid. Is it clear? Which may be calculated as x1 plus x2 plus x3 divided by 3, y1 plus y2 plus y3 divided by 3 if x and y are coordinate of their vertex. Is it clear?
Yes, sir.
Similarly, suppose you have a square. So if you draw a line of symmetry to this, it will be along this direction, along this, or it will be along its diagonal. So all will intersect at this point, which will be the midpoint of this square. Similarly, if you have a circle, so we'll say center of mass will lie at its center, which will be intersecting point of its line of symmetry, and that will be intersecting point of its diameter. Let's say along this direction, along this direction. So it will be at this point. Is it clear?
Yes, sir.
You all have written?
Yes, sir.
Now let me define you some unsymmetrical body. First is semicircle or semicircular ring. This is x-axis and this is y-axis. So you will say this body is symmetrical along y-axis. So if a body is symmetrical about x-axis, its y-coordinate would be at origin. And if a body is symmetrical about y-axis, its x-coordinate will lie at origin. Okay? So center of mass of this semicircular ring will be at this point, whose coordinate will be 0, 2r by. Is it clear? Hamza, is it clear?
Yes, sir.
Now suppose if you have semicircular disc. So its center of mass would lie at this point, whose coordinate will be 0, 4r by 3 pi. This is semi-circular disc. Next is cone. Hollow cone means empty from inside. So its center of mass would lie at this point, 0, h by 3. H will be total height. Next, for solid cone, draw a line that will be positive y-axis. It will be at this point, which is 0, h by 4. Is it clear? So you have to remember all these things. You don't have to derive these terms. First, write it down to this part. You have written till this part? Hamza?
Yes, sir, done.
Now there is a question related to this. A square plate having side L and circular plate having diameter L, both having same areal density. Are placed side by side. So in which body position of center of mass will lie, and how you'll calculate that? Is it clear? Let me define you by diagram. Suppose you have a square and a circular plate like this. We have two bodies. One is circular plate and the other is square plate are placed side by side. So we have to define in which body center of mass or position of center of mass would lie. Khalid, any guess?
Sorry, sir. What was the question again?
In which body center of mass will lie? It will be in circle or square.
Sir, I think in the middle of those two.
Okay. Hamza, any guess? Salman,
Sir, in the middle of them.
okay. Suppose if you calculate mass of each body, is it one-dimensional body, two-dimensional body, or three-dimensional body? Heba?
Two-dimensional.
Good. So mass of circular plate will be sigma times area of it, as sigma equals to mass by area. So mass is equals to sigma into area. Since L is diameter of the circular part, so for radius, it will be L by 2. So area of circle is pi times r square. So you'll get sigma pi L square by 4. Is it clear?
Yes,
Hamza?
sir.
Okay. Similarly, for a square plate, you may write it as sigma times area, and area of square is side square. So you'll be sigma times L square. Now try to compare the two masses. Are they equal or which one is larger? Hiba, tell me. Which one is more? Mass of circular plate or mass of square?
The mass of square.
Good. And above, I defined you, center of mass will lie towards heavier body. It's in this part. Position of center of mass will always lie towards heavier body. So what do you conclude about this? So in which body center of mass would lie?
On the circular plate.
square.
Khalid, just think again. You'll say since mass of square plate is more than mass of circular plate and center of mass lies towards heavier body, so it must lie on square plate. Is it clear? Now the next question would be, find position of center of mass for this problem. So how would you find it? So for any problem, first try to define using coordinate system or try to draw coordinate related to that diagram. So if you draw coordinate system, x-axis, y-axis to this diagram, someone say, take the center of a square plate to be at origin and draw coordinate axis from them. Or some other will say, take this particular distance to be at origin and draw axis along this. It will depend upon your choice. Now, this is x-axis, this is y-axis, and I have taken this point to be origin. So with respect to this origin, we may define position of center of mass of individual body. As we know, circle is symmetrical body, and for all symmetrical body, center of mass will lie at its midpoint. So it will be at this midpoint, which having coordinate L by 2, 0. Similarly, for a square plate, it will be at this point, which will be L plus L by 2, that is 3L by 2, 0. Is it clear?
Yes, sir.
Khalid, any doubt?
No, sir.
Now you have both coordinate of each body and mass of each body. Now we can treat this particular two body system as two particle system. So use the formula x center of mass as m1x1 m2x2 divided by m1 plus m2. m1 is mass of circular plate, which is sigma times pi L square over 4. x1 is its coordinate, L by 2. m2 is mass of square plate, sigma times L square, and its coordinate is 3L by 2. Whole divided by total mass, sigma times pi L square by 4 plus sigma times L square. So on simplifying it, you'll get your answer of position of center of mass. Is it clear?
Yes, sir.
Okay, just write it down. You all have written to this part?
Yes, sir.
Salman,
Sir,
any
we have
doubt?
to further write this answer.
Sir, can you like write the answer after this?
Okay. If you simplify it, take sigma times L squared to be common from its numerator. You're left with pi by 8 plus 3 by 2 times L divided by sigma times L squared pi by 4 plus 1. So this sigma L square and this sigma L square will cancel out. If you further simplify it, take 8 to be LCM of numerator. So you're left with pi plus 6. Pi plus 4 divided by, if you take 4 to be LCM of this part, you will get pi plus 2. Just 1 minute. 3 into 4 will be 12. 8 divided by 4, it will be 2. So 2 will be at this point times L, or you may simplify it to get pi plus 12 times L divided by 2 pi plus 4. So this will be your final answer. Is it clear? Khalid, is it clear?
Yes, sir.
I didn't think of taking common, so I just multiplied and did.
Okay. By using this method, calculation will become easier. You all have written?
Yes, sir.
Now there will be question related to this. To give an example of a body whose center of mass will lie outside the distribution of mass. My question is, to give example of a body whose center of mass will lie outside the distribution of mass. Position of center of mass outside the distribution of mass. So first body will be a ring. For this ring, mass is distributed uniformly at its boundary, but its center of mass will be at its midpoint, which is outside of its distribution of mass. Similarly, for L-shaped body, if you calculate its center of mass, it would be at this point outside to this body. Is it clear? Hamza, is it clear?
Yes, sir.
Okay, just write it down. I'm giving you one problem related to this. We have three square, each of mass m, and side L are arranged like this. So you have to find position of center of mass. So first try to define coordinate axis. Let's say it will be like this. Using coordinate axis, first try to define its center of mass of individual body. As we know, square is a symmetrical body, so its center of mass would lie at its midpoint. So first, it will be at this point. For second, it will be at this point. And for third, it will be at this point. Mass of each block is m. Try to find position of each term. Then use the formula for discrete particle system, m1x1, m2x2, and m3x3, divide by total mass, m1 plus m2 plus m3. Similarly, you get the value for y center of mass. Hamza, is it clear?
Yes, sir.
Try to solve. Using this diagram, if you define coordinate of center of mass of each body, so for first, it will be at L by 2, comma L by 2. For the second, it will be at 3L by 2, comma L by 2. And for this, it will be L by 2, comma 3L by 2. Is it clear? Salman, any doubt?
No, sir. I was doing this. I got answer.
Okay. Now put all the values in this formula. Take the value of M1, M2, M3 to be M. Hamza, any doubt?
No, sir. Doing it.
Okay. Good, Khalid. M1 is M, L1 is L by 2, M2 is M, L2 is again 3L by 2, M3 is M, and L3 is L by 2. Divide by M plus M plus M, that is 3M. Take out M and L as common. So you're left with 1 by 2 plus 3 by 2 plus 1 by 2. On solving, you will get 5 by 2. Divide by 3M. M and M will cancel out. So it will be 5 by 6 times L. Hamza, is it clear?
Yes, sir.
Similarly, you get YCM as 5L by 6. Khalid, is it clear? Iba, any doubt?
No, sir.
So this is all about the basic concept of calculation of position of center of mass. So just revise this whole part and try to do more and more problems related to this. In next class, I will define you some of more depth concept of the center of mass. Then we'll start moment of inertia, the second topic of this chapter. Okay.
Okay, sir.
Okay then. Take care. Allah Hafiz.